Okay, let's look at rationalizing the denominator of this expression. This is number 39 in section 8.4. And notice what I want to do is multiply this by 1. But the form of 1 I'm going to use is going to have the smallest, so since the denominator has a square root, I'm going to be multiplying by some square root over itself. And one of the things I might want to do with 45 is I might want to think of 45 as, since 45 is 9 times 5, I might want to think of it as 3 squared times 5 times x cubed times y to the 4th. So what I want to do is I want to multiply the top and bottom by the square root of the smallest number or smallest expression that makes, after I multiply, me take the square root in the denominator of a perfect square. Well, I see I already have 2 powers of 3, but I only have 1 power of 5. So I need 1 more power of 5. I have y to the 4th is already a perfect square, so I don't need to do anything to that. But x cubed is not a perfect square. So if I multiply that by 1 more power of x, then I'll have a perfect square power of, or an exponential that's a perfect square. Because remember, my exponentials are perfect squares if they are evenly divisible by, the powers on those exponentials are evenly divisible by 2. So in the numerator now I have 9 times the square root of 5x. In the denominator I have the square root. I still have 3 squared. But now when I multiply 5 times 5, I now have 5 squared. And x cubed times x is x to the 4th. And then I just recopy the y to the 4th. So everything in the denominator's radical is a perfect square. So this is 9 times the square root of 5x over, and now let's apply the square root to this. The square root of 3 squared is just 3. The square root of 5 squared is just 5. The square root of x to the 4th is x to the 2nd. The square root of y to the 4th is y to the 2nd. And remember, to get the square root of an exponential, I simply, since a square root has an index of 2, I'm simply dividing each power by 2. Anything that's an x, all of these are exponentials. So the square root of 3 squared is 3 to the 1st power. I divide the index of 2, unwritten index of 2, into these exponents. So this is 3 to the 1. 2 divided by 2, the power on 5, when I apply the exponent, is 5 to the 1. When I divide this power 4 by 2 on x, I get x squared. And similarly, when I divide the power on y, which is 4 by 2, I also get y squared when I apply the radical. So this is 9 times the square root of 5x over 3 times 5 times x squared times y squared. And I do need to write it in simplest form. This 3 divides evenly into this 9 3 times. So my final answer is 3 square root 5x over 5x squared y squared.